Hey, algebra students, in this lesson, we are going to be learning about graphing inequalities. And we're going to start off with a little bit of background on this one. First of all, we're going to be dealing with linear inequalities in one variable. Now, usually when you hear about graphing, you think, oh, great, this is going to be graphing. Like I got to deal with the x-axis and the y-axis and coordinate pairs. But we're not going to worry about two axes yet. Because we're dealing with one variable, we're actually going to be dealing with graphs that look like this, a number line, one-dimensional graphs. Okay, so this is actually going to be pretty easy. We are going to be dealing with the symbols less than and greater than. When something is less than or greater than, that means that it's not the same as. Okay, so if I have like ax is less than b, x is a variable. Let's say that a is just 1 and b is 5. That means that x can be anything less than 5. Can it be 5? No, it's not allowed to be the same thing as the other side of the inequality. It has to be less than 5. If I want it to also be equal to, I can use this symbol, less than or equal to, and then greater than or equal to. These are the symbols that include the thing on the other side of the inequality. And then lastly, there's also unequal. That means that the number on the left can take on any value except for what's on the right side, the equal sign. Okay. The solution to any of these statements in inequality is actually not just one number, but a set of numbers. Usually it's a set of values that satisfies the inequality. And then equivalent inequalities. One of the things that we could do is use the rules of algebra to rearrange inequality. We can add things to both sides, subtract things from both sides. And when we use the rules of algebra, we write equalities that have different symbols, different numbers in different places, but they're actually the same inequality because they have the same solution set, even though they have a different representation of the solution set. All right, let's get started. Letter A, determine which of the values -2, 0, 5, and 11. Notice this is in set notation. Which of those values are part of the solution set for the inequality 3x plus 4 is less than 19? I could rearrange this inequality and write an equivalent inequality that has x on a side by itself. That would make it really easy to solve. But you know what? This one's really easy to solve by just putting in -2, 0, 5, and 11 to the equation. So what happens if we plug in -2? 3 times -2 is -6, plus 4 is -2. If I plug in -2 to this, I get -2 on the left side. -2 is less than 19. That is a solution because -2 is actually less than 19. What about 0? Plug in 0, I get 3 times 0 is 0, plus 4. 4 is less than 19. 0 works. What about 5? 3 times 5 is 15, plus 4 is 19. 19 is not less than 19. So because 5 makes this 19 is less than 19, and it's not true, 5 does not work. And 11 is not going to work either. 3 times 11 is 33, plus 4 is 37. 37 is not less than 19. 2 and 0 are the only two values from this set that are part of the solution set of the inequality. Now, how many more solutions are there to this inequality? There's an infinite number. I do -20, -30, -1,000,000. There's an infinite number of inequalities or solutions to this inequality. How do we show when there's an infinite number of something? Well, we can show that with a graph. And that's what we're going to do here for letter B. Letter B, we have to graph the solution to the inequality. U is greater than -2. What's that going to look like? Well, okay, so I need to put some symbols on this number line over here to show U is greater than -2. First thing I'm going to have to do is put a circle on -2. So let's do that. And I'm going to start with a circle that is empty, okay? Now I have my circle at -2. The next question I'm going to ask, do I fill in my circle? In other words, is -2 one of the solutions to the inequality? -2 has to be greater than -2, but -2 is equal. It's not greater than or equal, it's just greater. So because of that, if it's just greater than, I have to leave this symbol, this circle empty to show that -2 is not actually one of the solutions. But anything greater than -2 is a solution, like -1, 0, 1. Those would all work. So what I need to do then is put a line going this way. Okay, we're going to do that. And then when I got my line going to the right, I'm going to make that line really heavy. If I were doing this on paper with a pencil, I would shade this line. I'm not going to shade it ridiculously thick so I can't see anything underneath it or what's going on, but I'm going to shade it so that I can clearly see that this side of that point is all of the solutions to the inequality. And that is how you do one like letter B. Let's do the next one. Okay, let's see if I can get this image here grabbed. There we go. All right, excellent. So letter C is going to be the same sort of thing. For letter C, t is greater than or equal to 2.5. Well, it's going to be the same setup, except now I have to go up to 2.5, which is going to be there. I need to put my circle at 2.5. Now here I have to ask myself, okay, this says greater than or equal to. Do I fill in my circle for greater than or equal to? And the answer to that is yes, I do have to fill in my circle because 2.5 is actually one of the solutions. So I'm going to go ahead and do that. And then I am going to grab the end of this line. We'll just make it a little shorter there. There we go. All right. And that is how we would show t is greater than or equal to 2.5. Now, wait a second. I put that at 2. Let me make sure that's clearly at 2.5 right in the middle there. Okay. Now, we'll go on to the next one, letter D. Y is less than or equal to 3 1/3. Well, first of all, I'm going to put my point at 3 1/3. That's going to be like there, 1/3 of the way between 3 and 4. Now, my next question is, am I going to fill this in or am I going to make it empty? I have to fill it in because it's or equal to. So 3 1/3 is a solution. Then I'm going to take the rest of this line and we're going to put it on the left side here and have it extend in this direction. Okay, excellent. And then lastly, we've got one more of these, letter E. So let me just keep labeling these. This one's C. This one is D. And then we have one more down here, which is going to be E. For E, I have 0 is greater than V. So 0, I'm going to put my dot at 0 right there. Okay. And 0 has to be greater than V. This is in a different direction. All the other ones were, let's see, actually, no, I'm sorry. This one is less than, this one is greater than. What's a way that I can tell if I'm putting the shading on the right side? Well, one of the things I could do is just check a number on the side of the point that I put. So I have to put a point at 0. I have to ask myself whether that point's going to be filled in. This one is just greater, not equal to. So this one's going to be an empty circle. And then what I'm going to do is I'm just going to pick a point over here to the left to see if a point on the left works. -6. If I plug in -6 for V, does that work? 0 is greater than -6. Yes, that works. So that means that all points on this side of 0 have to work. If I would have chosen 3, 0 is greater than 3, I know that that's not true. So that means that this side doesn't work. It must be the other side. So if you want to just kind of picture yourself choosing a point and seeing if that point works, that is a valid way of exploring which side you have to shade. All right, now let's do the next one. We're going to go down to letter F. Write an inequality for the graph. This one, let's see, 0, 1. It's halfway between 0 and 1. So it's going to be x is greater than 0.5 or 1/2, right? Greater than 1/2. And it's not going to be greater than or equal to because the circle's not filled in. Letter G, 12. Let's see, I'm going to start with x. X is greater than or equal to, I got to use greater than or equal to. Let me just grab that symbol from up here. X is greater than or equal to 12 because it's a filled in circle, so it has to be greater than or equal to. Letter H, move this up a little bit. X is less than let's see, and here we have 45 because it's halfway between 40 and 50, so it has to be 45. Letter I, X is less than, because it's shaded to the left. And let's see, what number is this? X is less than 2. Now, is that right? Let me just consider. Is 2 a solution in this? Yeah, it's filled in. So it can't just be less than, it has to be less than or equal to, because my circle is shaded. All right, and then lastly, letter J. It tells me to graph this. I'm not going to graph this because it's too hard for me to make a number line that this will work for, but you get the point with graphing anyway. This says the boiling point of a liquid is the temperature at which it changes to a gas. The boiling point of water under normal atmospheric conditions is 100 degrees Celsius. Write an inequality represent the temperatures for which water is a gas. Well, okay, hold on. It changes to a gas at 100, so any temperature above 100 is a gas. What about equal to? The boiling point is the temperature at which it changes to a gas. The boiling point of water under normal atmospheric conditions is 100 degrees Celsius. It's not really clear if is equal to is part of the solution, but we're going to say that if it changes to a gas at 100, that means it's a gas at 100. So we're going to say that it is or equal to. So the way that this is going to look, you always have to make that choice, by the way. Sometimes it's more obvious than others. This one I would probably have to accept both ways. We're going to say X, the temperature, or maybe T, the temperature. That may be a better variable to choose. T is greater than or equal to 100 degrees Celsius. And that would be our inequality. And if I were to graph this, I'd just put a number line with 100 on it, and then I would shade to the right of 100, making sure my circle was filled in. And that's how you do this. You are ready to do the problem set for this assignment.